Hi, this is Nathan. The next example I want to do is the normal distribution. Specifically, I want to do when sigma squared is known. And we want to estimate the mean. So we have the marginal PDFs. We have 1 over square root of 2 pi sigma squared e to negative 1/2. We have xi minus mu over sigma all squared, which means joint PDF, that's going to be f of x1 to xn, which is equal to the likelihood function. We're estimating mu. It's equal to product from I equals 1 to n, 1 over square root of 2 pi sigma squared e to negative 1/2. I'm just going to rewrite this part to have the squared on top, so xi minus mu squared over sigma squared. Right, so now we take the log likelihood function. This is going to be equal to sum I equals 1 to n of ln of 1 over square root 2 pi sigma squared e to negative 1/2 xi minus mu squared over sigma squared. Or just distribute in the log. We have ln of 1 over square root 2 pi sigma squared plus, and now the log and the e cancel out, so negative 1/2 xi minus mu squared over sigma squared. Now take the derivative with respect to mu, and this whole ugly first term has no mu's in it, so the derivative of that is 0. So we have sum of negative 1/2. Now I'm actually going to expand this, so xi minus mu squared equals xi squared minus 2xi mu plus mu squared, right? So then the derivative with respect to mu gets us, this is 0, so this is 2xi, and this is 2 mu. So this is, what did I say, negative 2xi plus 2 mu all over sigma squared. Right, and now I'm gonna multiply in this summation, and we have sum of xi minus, because we have minus and a plus instead of minus and a minus, n mu, because we're summing it n times, over sigma squared, and we set this equal to 0, which gets us sum of xi over sigma squared equals n mu over sigma squared, or multiply both sides by sigma squared and those cancel out, which gets us sum of xi equals nu, or mu hat MLE equals sum of xi over n. Now, 2 takeaways. 1, once again, mu is the mean of this distribution, of the normal distribution, so it makes a ton of sense that the maximum likelihood estimation for mu is going to be equal to the sample mean. And observation number 2, is that the PDF which was 1 over square root 2 pi sigma squared e to negative 1/2 xi minus mu. This whole first part, right, has no mu's, right? And we just noticed that that's going to get canceled out because you're going to take the log and this whole part is going to have a derivative of 0. So if we want, we could just drop this whole thing right away, right? Because if we found the MLE using just e to negative 1/2 xi minus mu over sigma squared, that would get us the exact same maximum value that we had. So it's really up to you if you want to drop this term in front or not. It will make it a lot less, it makes it look a lot simpler, but it's going to get canceled out anyways.